Now, one of the areas where other programmers have always looked down on us SQL Server developers with disdain, and they sort of tease us behind the schoolroom about or something, is the way that T-SQL would trap errors. And basically, SQL Server was really, really bad at trapping errors before. In SQL Server 2005, they introduced the try-catch, and it may not be the most glorious implementation of try-catch, but at least it's something, and we have some real error trapping, finally. So let me show you how this works. There's basically two phrases here, or two blocks of code. The first one is going to be the code that we're going to try, and if everything works fine, the code ends with that end try. But if there are any errors while we try to execute this code, execution is immediately passed down to begin catch, and then the catch code is executed where we can handle any errors. So, for example, here's begin try, our first block of code, and the end try. So this is the full try block. Then there's the catch block with the begin and the end. Then finally I have some extra code at the end just so we can see how code continues on after the try catch. And one important syntax note here is that although it looks like two lines of code, end try and begin catch actually function as one set of code, so you can't have anything else in between the end try and begin catch. Not even a semicolon, that'll give you an error. In our try, we're going to do set no count on, which is a typical setting which tells SQL Server don't pass back the number of rows affected. A lot of times front-end programmers don't want to have that. Then we select a string literal of try1, and then I'm saying raise error. This will cause SQL Server to simulate as if an error happened and will knock us out of this try. And then just for testing purposes, I have some more code here for try2, a second line within the try. Then here is catch block, which I always think is funny. It makes me think of that movie Down with Love with Catcher Block in there. Dun, 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 dun. So anyways, we'll execute this and walk through and see what happens. Try1 executed. The error took place, dropped us down to the catch. We had select catch block, and then execution continued on with our select and try3, just as we expected. Within the catch block, there's a number of error functions that will turn to us information about what happened, what went wrong. And I have these listed out here: error message, error procedure, line number, severity, and state. And a real nice thing about this, as opposed to the old way of working with errors, is that it really retains the information. It doesn't lose it right away with another line being executed. So just to show you all of this information coming back, here's try1, then here's our catch select saying simulated error, which was the message we passed up with the raise error. There's no real procedure name here. It executed on line 4 was the error. There's the error number, severity, and error state. This is just to say, without the catch block, these are meaningless. They really are error functions only within the catch block. Now, let me go ahead and show you some of the older ways of working with errors, because I'm sure you'll run into this in your code. The @error would return the error number of whatever error occurred with the previous statement, but only the previous statement. Every statement will reset @error. So, if the first statement has an error, and then the second statement says print @error, the third statement, this statement, will only present us which error occurred in the previous statement. So, if print @error runs okay, this second print @error will say, hey, the previous statement worked just fine. Just to prove that out. And this happened on purpose, so don't freak out on the red code there. So what happened was, when we updated a person and set person ID equals 1, well, we can't set person ID because it's a primary key constraint and we can't make a duplicate. So we can't set person ID equal 2, change it to 1, because then we'd have two person ID 1s. So that update command gives us an error, which is what we wanted it to have happen so we could see an error. Down here, here's the message, the violation from the error, statement terminated. Then print at error is what generated this 2627, which was the number of the error that we had. And then print at error again gave us a 0 because the previous statement did not generate an error. And as you can see, this is one of the clumsiest ways to work with errors ever. The only way to handle this is after every statement where you expect that you might possibly get an error, you have to put this code in to have some kind of local variable capture at error into what is usually called just an our local error variable, and then say if this is other than 0, an error occurred, and then put all this error handling code in there. Might be a rollback, might be a return, might be a raise error, which I'll show you in a few moments. But good, solid, robust T-SQL code would have to go through this after every command that might generate an error, which was really laborious. Similar to at error is the at row count. And what you could do is you could say if at row count is equal to 0, meaning this update command really didn't update anybody. It didn't generate an error, but hey, we wanted to update person ID equals 100. We expected that to happen. Nothing happened, so there was some kind of error there. So this is another process we'd have to go through, is knowing that nothing happened and then having some error handling code. So as you can see, writing robust code that always handled every error in T-SQL store procedures was extremely laborious and tedious and just downright ugly. And I'm really glad that we have the try-catch now in SQL Server 2005.